Section 4.3 is L'Hopital's rule. L'Hopital's rule, we're going to be taking limits. They're going to be in indeterminate form, but now that we know how to take the derivative, we can do it using L'Hopital's rule. Okay, so in the first example, we've got L'Hopital's rule to find each limit. The limit as x goes to 2 of x to the fourth minus 16 all over x cubed minus 8. This is a rational expression, so we're allowed to just plug the 2 in for the x and see what happens. Well, when we get 2 to the fourth, that's 16, so we get 0 on the top. 2 cubed, that's 8, so we get 0 on the bottom. So it's in indeterminate form. Well, before we would have to factor it all out and see if we could cancel some of the factors. But now we know how to take the derivative. We can use L'Hopital's rule. So what it says is if you get 0 over 0, and there are other forms, but we're just doing the 0 over 0 in this section, you can take the derivative of the top and the derivative of the bottom and see what happens. Okay, so we've got the limit as x goes to 2. Taking the derivative of the top, we get 4x cubed. Taking the derivative of the bottom, we get 3x squared. And now you can plug the number back in. Okay, so we can plug 2 in for x. 4 times 2 cubed over 3 times 2 squared. And we get 32 over 12, which reduces to 8/3. And see how much faster that was? So L'Hopital's rule is great. Let's try another one, part B. The limit as x goes to 2 of x squared plus x minus 6 over x squared plus 6x minus 16. If you plug 2 in, which you should do, you should try that out, you will get 0 over 0, so we'll use L'Hopital's rule. So we've got the limit as x goes to 2. The derivative on top is 2x plus 1. The derivative on bottom is 2x plus 6. And we'll plug the 2 in. So 2 times 2 plus 1 over 2 times 2 plus 6. And I got 5 over 10, which is 1/2. If you take the derivative and you find that you still get 0 over 0, you can do it again. Take the derivative of the top, take the derivative of the bottom, and then plug it in. You can do it as many times as needed until you can get the answer. Okay, in part C, the limit as x goes to 0 of e to the x minus 1 over x. Okay, well, if we plug 0 in, we get 1 minus 1, which is 0 on top, and of course we get 0 on bottom. So we can use L'Hopital's rule, take the derivative of the top and take the derivative of the bottom. So the derivative of the top, well, that's e to the x. And the derivative of the bottom, that's 1. So plug in 0, so we get e to the 0 over 1, which is 1 over 1. So we get 1. And in our last one, the limit as x goes to 0 of the natural log of 1 plus 4x all over x. Well, when we plug 0 in, we get just the natural log of 1, which is 0, and we get 0 on the bottom. So we can use L'Hopital's rule, take the derivative of the top, take the derivative of the bottom. Okay, well, the derivative of the top, we have to use the chain rule. Okay, so the outside function is the natural log of whatever you've got right here. So remember, the derivative of ln x is 1 over x. So it's going to be 1 over 1 plus 4x times the derivative of the inside function. The derivative of the inside function is 4. All over, the derivative of the bottom is 1. Okay, well, let's make that look a little nicer. This is just 4 on top and 1 plus 4x on the bottom. The 1 we don't need to write. So really, we're just plugging 0 in right here. So we get 4 over 1, which is 4. And that's what we're doing of L'Hopital's rule. So check out the notes and try out the homework.